Okay, so this is question number 4, has to do with some velocity versus time graphs. You may want to go back to Module 1 and look at the skill builders. There is a skill builder about velocity versus time graphs. But let's go ahead and I'm just going to briefly talk about velocity versus time graphs. So again, we're going to have velocity on our y-axis. We're going to have time on our x-axis. So what this is really saying is we want to find out how the speed of this refrigerator is changing over time. So let's imagine, because I don't want to give away the farm here, but let's imagine that our refrigerator is already sliding along on a frictionless surface. So it's moving along at, I don't know, 20 meters per second. And so when we first start caring about it, when we first click our stopwatch or our timer, it's going at 20 meters per second. So at time 0, when we first start caring, it's going at 20. Now let's ask it, 5 seconds later, at time 5, how fast are you going? Well, it's still going 20. And 10 seconds later, how fast are you going? 20. At 15 seconds, how fast are you going? 20. At 20 seconds, how fast are you going? 20 meters per second. So notice what kind of a graph that type of motion creates. It creates a horizontal line. Every time I ask the refrigerator how fast are you going, it gives me the same answer. That's a velocity versus time graph. So think about the motion that's being described in this question and ask yourself, what kind of a graph would be produced from this motion? Remember, the motion starts from a dead stop, gets the refrigerator going, slides for a while, then it tells you to apply some friction, and it comes to a stop. So think about what kind of graph would correspond to that overall motion.